This next set of directions is a little bit different. We're supposed to do some estimation here rather than just stick the number into the calculator. We are so used to calculator these days that we get kind of into a pattern here, and this understanding of this estimation is actually a powerful skill that you can develop, and this is how we had to do things quite a while ago before the calculators came around. Notice that 10 to the third power is 1,000. 10 to the fourth power is 10,000. This 8,970 falls between 1,000 and 10,000, which is 10 to the third power, and that's why this is going to end up being between 3 and 4. Let's do the same thing here. Doesn't this 293,000 number fall between 100,000 and 1 million? Well, this 100,000 is 10 to the fifth. I can see that because there's 5 zeros in it. And this 1 million is 10 to the sixth. So basically, I can say that our estimate here is going to be that this is between 5 and 6. Now, when you actually substitute that into a calculator, you will get 5.4675 if you round to 4 decimal places. Let's look at this next problem. 897 is between 100 and 1,000. 100 is 10 to the second power. 1,000 is 10 to the third power. So our estimate is that our answer is going to be between 2 and 3. And when you actually plug this into your calculator, you're going to get 2.9528, which is definitely between 2 and 3. And we knew it would be closer to the 3 because 897 is a lot closer to the 1,000. Let's look at this next one. A little bit different because we have decimals. Isn't this between 0.001 and 0.01? This is between 10 to the negative third and 10 to the negative second. So we would expect that our answer to this logarithm is going to be negative between negative 3 and negative 2. Aha! I found my mistake. This is not between 100th and 1,000. This is in between 100th and 1/10. Ignore that right there, 1/10. Because if you think about it, I was looking at that third decimal place out. This is really 3 100ths, which is between 100th and 1/10 when you go 0.1 in the other direction. So our value should be between -1 and -2, and when you substitute that into the calculator, you do get -1.4202. That one threw me for a loop for a second, so let me kind of explain it a little bit more in this next problem. This value here, ignore the 1 on the end for a minute. This really here is between 0.0001, that's with a 1 being less than that where that 6 is, or 0.001. This is 10 to the negative fourth and 10 to the negative third. We're going to expect our answer to be between -4 and -3, and it really is, when you substitute it into a calculator, -3.2147. This next problem is, as you can see, a little bit larger than 10 to the 8th power. This will be between 10 to the 8th and 10 to the 9th, and so our answer should be between 8 and 9, and it is when you write 8.9590. Now, let's look at this one here. That 10 to the negative second power means move the decimal 2 places to the left. So we have 0.082, which is between 0.01 and 0.1, and that means this is going to be between 10 to the negative second and 10 to the negative first. So we're expecting something between -1 and -2, and the answer here is -1.0862 when you substitute that into a calculator.